My name is Kevin. Together with my co-founders, Brandon and Agron, we started Synaps. We are building the fastest architectural design tool in the world. Think of it as basically a modern version of AutoCAD. It's in the browser, it's collaborative, you can go in with your clients there, and you can basically design in real time. Of course, when you make claims that you're building the fastest architectural design tool in the world, you have to think of the AI implications with it and how architects are currently using AI. And we started talking to architects, and of course, there are quite some interesting things happening. But most of them are image-based, like this Mid-Journey example. You have a prompt, you give the prompt to the Mid-Journey chat, basically, and it generates a specific picture or a specific image. That's all well. You can even let your imagination run wild, and you can even ask it to create habitats on Mars, and it will still generate something. But when it comes to actual use cases, if we take a simple example, a generation of a simple plan, maybe there are some things here that you don't like. Maybe you don't like the way 2 or 3 of those trees look. So what you do is basically you put everything in Photoshop and then you have to edit it and so on. And or the other alternatives is to just go to Mid-Journey again, insert the prompt, and pray to the gods of AI that something meaningful comes back. So that's where we actually started understanding a lot of the issue. Everything is image-based, and there's nothing you can do more with it. So you generate this image, and there's absolutely nothing more you can do with it. And then we started talking to architects, and we discovered quite a lot of interesting things. But we came to these conclusions after the end of our research. AI will help architects in their decision-making. We can generate much more optimized and innovative designs. And the most important thing is that we can actually approach social impact completely in a new, different way. Now, architects can take away all the boring manual stuff, and they can focus on creativity. They can focus on their passions and thinking really hard about problems. Of course, this comes with challenges. We have, for example, the necessity for high-quality data in order to train these models, and they can basically generate only the things that they are trained upon. While talking to architects, we dove a little bit deeper, and specifically in urban planning, which was part of our research, we saw that there are 2 approaches. So the top-down approach, where you get a whole neighborhood, you have government regulations and zoning regulations and housing policies and environmental regulations, and then you have to consider all of these aspects. And then there is the bottom-up approach, where you basically have community needs and local economic incentives and green space allocation. And the architect has to switch between those 2 aspects all of the time. And it gets sometimes overwhelming. But the biggest problem there is that you're working on assumptions. You have a volume, and then you assume that is exactly, this many people will be living there, this many parking spaces are needed. So we came up with a better approach. We thought, okay, we have a platform, it's in the web, it's collaborative. So what if we had a space and then ask AI, our own model actually, to generate not images, but objects. So actual walls, actual windows, actual doors, and then you can play around with it. If you don't like something, you can just switch it up and play around with it. This minimizes manual work, especially in the schematic phase. Architects can focus on creativity and style, and all of these aspects like demographic composition, infrastructure requirements, environmental factors can be taken into account directly when generating stuff. So other things that we take into account when generating a floor plan are the exterior of the building, the interior composition of the building, of course, the structure, basically load-bearing walls, where the load-bearing walls are and how the whole thing is conceptualized, communication between different apartments and different rooms of the house, and of course the orientation, the north orientation, south orientation, because of environmental aspects like sun, wind, and so on. How does it actually work? Well, we are at the beginning phases of our research. The first thing is we thought of it this way, that you generate a floor plan for a single apartment, and then you extrapolate it to the floor, and then you can ask it to generate the same floor or with differences for the building, and then you can literally do that for the whole neighborhood. So in a couple of seconds or minutes, you might have a whole neighborhood plan with actual floor plans. And now you can repeat the generation as necessary, and then you can extract this information. So in a couple of minutes, you plan a neighborhood, and you know exactly how many people live there, how big the rooms are, how many parking spaces you need. So all of that information is there. And if the architect decides to change a single apartment, that information is automatically updated. So the best thing about this is that you can do tweaks directly in Synaps. So it's not only one floor plan, it can be multiple floor plans. So the tweaking ability, that you are generating something that is meaningful and senseful, makes the difference, basically. This is what we, as I said, we are in the beginning phases of our research, and this is an example of a simple floor plan. And with this simple floor plan, we use the Voronoi diagram method, and we have different weights here for each specific room. The dark yellow room is, in this case, the living room, and we tell the model that the 40% of the space should be allocated to the living room, and then the 3 other rooms should be allocated with 20%. And then we can also tune at this stage the communication between the rooms. So the living room should be connected to all of the other rooms. And this is basically what the existing state comes up with. Of course, a lot of the research is based on existing research, and there is some really well done work there that helps us a lot. But now we have some amazing data scientists in the team, and we will be pretty far soon enough. What's the general project impact? Well, you can have, as an architect, data-driven decisions. You address social impact directly from the start, and not as an afterthought. You have a rapid generation and evaluation of multiple design options, so you can have a whole building design, but you can have also 4 and 5 other different options, depending on which kind of people, for example, you would like to live here, or depending on the demography. There is a lot less manual work involved, so it's less prone to errors, because the architect now does only minor corrections and focuses on the concepts rather than actually drawing walls themselves. And the best thing also, what I think about this is that it's evolving. So it's not a static thing. While trends evolve, while models change, you feed it new data, and then it can understand this new data and see how these trends are evolving. So it will always generate you up-to-date floor plans, up-to-date concepts. And we like to think that we are also helping in the democratization of the planning process. Now, it's not anymore about who has the biggest manpower, but it's about who has the biggest creativity, because manpower can be substituted by AI, especially the things that do not require creativity. And overall, we believe that we can directly impact the way that we build our world. We can directly impact and generate a higher livability index for all the people. Future development, well, we just received a research grant from the Austrian government, and we want to be the first production-ready floor plan generation in the world. We are also doing some research in other things like interior composition. So how do you furnish an apartment on the best way possible? And what I also like really much is the historical blueprint interpreter. So in Austria specifically, there are a lot of old buildings, and these buildings are actually hand-drawn. Their plans are hand-drawn, are not digitalized. So we are thinking, okay, what if we actually figure out how to understand all of these annotations and create objects in Synaps, so you can also have historical building digitalized. And whenever you need renovation work, for example, done on those historical buildings, the architect doesn't need to manually draw everything all over again, but you can simply share a Synaps project. What's next for Synaps? Well, we'd love for you to join our beta. In the coming months, we're gonna launch a simple version of the product. The AI generation will not be there yet, it's still experimental, but we'd love to hear your thoughts on it, and yeah, support us on LinkedIn and, as Jeleza said, YouTube. We just started our channel. Thank you very much.